In the previous video, I've shown you how to define a function called reverse, which displays the contents of the array in reverse order. But here now, let's define another function. Let's name it as a reverse in array. As you pass name of the array and the size of the array, and now we have 6 elements in B, and then this function actually reverses the contents of the array. It's not simply printing the value, but the array itself is updated by reversing those elements. So once the B is now reversed, you can call show array function with the array name B and 6 elements. Then this function show array will show that the B is reversed. So let's define array reverse function. So void reverse in array, name of the array is passed and the size of the array is passed. So let's define that reverse in array, name of the array, let's have it as M, and then size of the array is provided. So here let's find some idea. So in this example, array B has 6 elements. So array index is 0, 1, 2, 3, 4, 5. So to reverse the array, what we need to do is 0, the data at 0 and then at 5 should be swapped. And then from both sides, just move inside the one element, then 1 and 4 are swapped, and then 2 and 3 are swapped. If we exchange those values by swapping this way, then we get the array itself is reversed. So in general, suppose we have array is a size, then how do we swap that? And 0 and the very last element is size minus 1 is the last element. So the first element 0 and size minus 1, those should be swapped. And then at index 1, what we need to swap is second to the last one. So last index is size minus 1. And then if we subtract 1, it's a second to the last one. And with the index 2, we need to swap is a size minus 1 is the last one. So if we subtract the 2, then those are something we need to swap. Then the last one we need to swap is size half of that. Let's see what is that. So if in this example size is 6, if we take half of the size, it is just 3. So 3 is actually the beginning index of second half. So we need to swap 2 and 3 means 2 is half of the size minus 1. So half of the size minus 1 is the last one to be swapped with the size, half of the size is the one. So this is the relationship we find. Then in terms of implementation code, that should be something like this. So we need to do a loop and then let's change I from 0 to half of the size, less than half of the size. So half of the size minus 1 is the last one for swapping in this picture. So 0 through half of the size minus 1, and then increment I. Then what we need to do is swap array M at index I, swap this one. So if I is 0, what you need to swap is M size minus 1. In I is 1, swap size minus 1 minus 1. So here, as I showed in here, if I is a 2, swap size minus 1 minus 2 and so on. So what you need to do here is minus I is the one to be swapped. So swapping two variables, we have learned in earlier chapter that we first need a temporary variable and save the value, and then in this variable we can override with the other value you want to swap, minus 1 minus I, then size minus 1 minus I should be reached from temp variable we have saved. So this is how to swap two variables. So index 0 with the size minus 1, index 1 with the size minus 1, minus 1, and so on. So those swap is done. And then that completes the reverse in array function. So let's compile the program and then run it. Then see that the result it's a reverse. The array is displayed by show in array function. So B itself is reversed. Here we need to consider one more thing, is that in this example we had the 6 elements. It's a even number. What if we have other number? Other number means we cannot split the array into two halves. Then let's see what happens for that. Is this algorithm still works? That is the actual question. So suppose I have one more element. So 1, 2, 3, 4, 5, 6, 7. So index 0, 1, 2, 3, 4, 5, 6. Now size is 7. So in this algorithm, we do index change 0 through 1 less half of the size. So half of the size is still 3. 7 divided by 2, integer division is still 3. So index goes 0, 1, 2 as well. So here the loop goes 0, 1, 2. And using those 0, 1, 2, we swap corresponding one. So 0 with the very last one swapped, 1 with the very last, the second to the last one swapped, 2 with the 4 swapped. So those two halves are swapped, but the one in the middle is not swapped. So this algorithm does not do anything, the one in the middle. Is that fine? Yes, in reversing, since 3 is exactly in the halfway, so you don't have to change anything. Only the left 3 and right 3, as they are swapped, the middle value remains unchanged. So this algorithm still works. So let's verify that. So if I give one more element in the array B, 70, and then let's reverse array B with the 7 elements, and then let's display the value. So compile the program and then run it. See that the algorithm still works.